In this video, let's try to understand how can we actually implement the get operation on a singly linked list. So the main purpose of get functionality on a singly linked list is to retrieve the node that is available at a specific index. So as part of this get functionality implementation, what exactly we request from the user is basically the index. Index is nothing but the position at which the node is requested by the user. So first, let's try to understand how the indexes actually work in the case of singly linked list. So it is not a complicated thing. If you happen to know arrays concept, right? We know in the arrays the index starts from 0 and ends at the length of the array minus 1. Similarly, in the case of singly linked list also, the index will start from 0 and ends at length of the linked list minus 1. So if I have to add the indexes to the nodes that we have inside the singly linked list, right? Let's try to do it on a sample linked list that we can see here. So here we have a singly linked list containing 6 values in it. So obviously the starting index will be 0 and the ending index will be length of the linked list minus 1, that is 5. So here the very first node, that is 10, will be available at index 0. Similarly, the node with the value code will be available at index 1. Similarly, the node with the value true we have at index 2. Similarly, all other nodes also we can give the index value. So as part of the get operation, if the user passes a certain index, right, we have to return the node that is available at that particular index. So we are expecting the index value also from the user from 0 till the length of the linked list minus 1 as part of the argument. So that is how we actually represent the indexes in the case of singly linked list as well. Now let's go ahead and let's try to understand what all are the different cases that could possibly come when we try to implement the get functionality. So let's just try to understand the different cases. Obviously here we are taking the index as an argument from the user, right? So user might not be aware of the length of the linked list and can give the index that is beyond the maximum possible index or any negative value as well. So we have to handle those cases as well. So as part of the first case, let's try to handle invalid indexes. So the minimum possible index is 0 and the maximum possible index will be length of the linked list minus 1. So any negative values or any values beyond length of the linked list minus 1 are actually invalid indexes because the nodes that are available are at index 0 till the length of the linked list minus 1 only. So if any other value comes, first what we have to do is we have to simply return null or none based on our choice of programming language. If you are using Java or JavaScript, you will simply return null. If you are using Python based programming language, you will simply return none in that case. Because user has passed some invalid index, that could be negative index or it could be the index that is not in the range of whatever the indexes that we have in the singly linked list. That is the case where we handle the invalid indexes. If the second case is actually the valid indexes given by the user. So if the user has actually given the valid index, right? So our job is to start at the head node and we have to go to the node that is given by the user at that particular index and we have to return the entire node here. Okay, we are not simply returning the value we have in the node, rather we are returning the complete node. Okay, why? Because we can reuse this get functionality in the future operations such as set, insert, delete, and all these functionalities we can reuse this get functionality. That's why we make sure that we are returning the entire node object but not the value. Okay, so how will we actually do that, right? So we will, let's assume that the index that user has given is, let's say, 3. So that means that my program should return the node that is available at index 3. That means I should return the node test as a output. So what exactly I will do is I will start traversing the linked list at the head node, because in the single linked list that I'm implementing, I have the access to the head node, I have the access to the tail node, I have access to the length of the linked list. Now Since I have the head node, I can start traversing at head node. From head, I can go to the next node, right? Because each and every node has the reference of the next node. That means if I go to the next node, I will be at index 1, which is not the index that user has requested. So on index 1, I will again read the next node. I will go on to the index true, right? Now this is at index 2. That is not the index that user has requested. User has requested the node at index 3. So again, from the next that we have on the node true, I will go on to the node with the value test. Now my index is 3. So I can simply return the node with the value test as a output here. Okay, so for going to the index that is available at a given index, we will simply be running a loop. How will I exactly run the loop? That I will show you when I write the pseudocode as well as the programmatic implementation. But this is how, this is the overview of how we can implement the get functionality based on the index that user is passing. Okay, now that we have understood the different scenarios that could arise while implementing the get functionality, right? Let's try to write the pseudo code for implementing the get functionality as well. So here what we will do, we will simply write a function called get, and here we will be taking the index from the user. So when we discuss the algorithm, right, what exactly we discussed, there will be two checks. The first check is to check if index is invalid. So how will we check if the index is invalid? Internally in the singly linked list representation, we are keeping track of the length of the linked list. That means we know the minimum range is 0 and the maximum range is length minus 1. If at all, if the user is, whatever the index that user is passing, if it is less than 0 or greater than or equal to the length, that means that is a invalid index. Based on that invalid index, if the user is giving, right, obviously we will not have the node at that particular index, so we will simply return null or none based on our programmatic implementation. If we are using Python, we will simply return null, none. If we use JavaScript or Java based representation, we will simply return null here. Okay, so this is the case if the index is invalid. Okay, as part of the next scenario, we have to handle the valid indexes. So anything that is not falling onto above range, that is if the index is falling in the range of 0 till the length of the linked list minus 1, that user has given a valid index. Now here what we have to do is, I will simply define a variable called current node, and I have the access to the head node, right? I will simply assign head node to it. Similarly, I will define one variable like counter and I will initialize it with 0, because right now the node that I'm processing is at the very first node, right? Let's assume that I have a singly linked list containing, let's say, 4 values. Let's say 10 code, let's say true and false. The index that user has given is 3. Let's assume 0, 1, 2, 3. This is the head node, this is the tail node. Since I am starting at the head node, right, the counter I am initializing it with 0. Now what I will do is, I will simply run a loop while this counter is not equal to the index that user has given. That means that I am not at the index that user has passed. Inside this while loop, what we can do, we can simply, we have the node reference. On the node we have the next available, right? So we will simply update current node variable with current node dot next. In that way we are simply moving on to the next nodes, and since we are moving on to the next node, the counter should be incremented by 1. So counter should be counter plus 1. Once we go to the index that is given by the user, right, the current node will be available at that index, and the current node variable whatever we are using will be having the reference of the node that is available at that particular index. So we will simply break out of this loop. In the end we will simply return the current node. Okay, this is how we exactly write the pseudocode for implementing the get functionality on a singly linked list. Now let's try to implement the get functionality in Python. So inside the singly linked list implementation class that we have written, I'm adding a function called get. Okay, so the first argument is the reference of current object and the other value is index. Okay, so we already discussed as part of the pseudocode, we assumed that this index is something similar to the indexes we have in the array. So basically the possible index range is from 0 till length of the single linked list minus 1. So whatever the index that user is passing, right, it could be out of non-valid index also. So to support such cases, what I will do, if the index is less than 0, that means the user has passed the negative index which is not available, or whatever the index that user has passed, if it is greater than or equal to the length of the singly linked list, self dot length. That means, sorry, here or, right? So these are the problems of implementing it in multiple languages. You often forget the syntaxes. So if it is more than the length of the singly linked list, that means the possible range is from 0 till length of the linked list minus 1. So even if user passes an index that is equal to singly linked list length also, we should not return anything. So in this case, we will return simply none here. Okay, if this is not the case, that means we will have to move on to the node that is present at that particular index and we need to return that specific node. So for that, what I will do is I'll simply define a variable called I and I will assign it with 0, and I will also create one variable called current node and I will assign it with the head node of the singly linked list. Now to go on to the node that is at this particular index, what I will do is I'll simply run a loop as long as this I is not equal to index that user has given. If this is the case, I'll simply go on to the next of the current node I'm right now at. So I'll simply update current node equal to current node dot next. Okay, once I'm moving on to next node, that means I am at the later index, so I will simply need to update I to I plus 1. Okay, this loop will break once we reach the value I matching with index, right? That means whatever the value or the node that we have at this current node is the node that we have at this particular index. So we will simply return current node. Okay, that's all. Very simple operation. As part of the first check, we need to make sure whatever the index that user has passed is in the valid range. The valid range is from 0 till length of the single linked list minus 1. So if the value is out of the range, we will simply return none. Otherwise, we will have to go on to the node at that particular index. For that, I'm defining two variables and I'm running the loop as long as this is the temporary variable I is not equal to index, and I will simply move on to the next node. Once I reach that index, this loop will break and I will have the node at that particular index inside the current node variable. I am returning that value. Okay, now let's try to execute it and validate the results. Let me just uncomment these lines and let me just comment out these 3 lines of codes. Anyway, we don't need to traverse or anything. Let me just call sll.get. Let's pass. We have 4 values in the singly linked list. So the possible range is from 0 to 3. So if I pass 0, it should basically get the first value in the singly linked list, which is 10. So let me just capture it. Result. Let me just print it. Print result dot value, because we are returning the node, right? The node can have the value in it. So let me just comment out these lines also, because we are not modifying the head or tail or anything. We are simply going and getting the node at the index that user has passed. Here 0 it is. So if I execute it, that means Python 3 singly linked list dot py. I should get the value at index 0. Index 0 means it is the first value, that is 10. Similarly, if I pass the index 3, that means I should get the value at the 4th position. So I should get 10.10. If I execute it, I got 10.10. Similarly, if I pass 2, that means we need to get the value at the 3rd position, that is true. So if I run it, I got the true. If I pass any negative value, I should basically get the none. So if from none, we won't be able to read dot value, right? So I'm just simply removing it. If I execute it, I got none. Similarly, if I pass any value that is more than or equal to length of the singly linked list, I should get the same thing. Okay, I've got the similar thing here. Okay, this is how we basically implement the get functionality in a singly linked list. Okay, in actual our project implementation, this get functionality is something that will be used a lot of times, so make sure that you are understanding it very clearly. Thanks for watching. I'll see you in the next implementation. And the time complexity and space complexity involved in the implementation process, and both these also let's just try to understand in terms of best case scenario as well as in the worst case scenario. So when will the best case scenario of get operation will actually occur? Whenever the index that user is passing, if it is equal to 0. That means that let's assume that our singly linked list contains some number of nodes, right? And we have the head node and we have the tail node. When the user passes an index 0, whatever the iteration logic that we are executing for reaching the node at that particular index, right, that will not even get executed. We will simply return the current node immediately. So obviously, since we are not running the loop, the time complexity will be order of 1 in the best case scenario that occurs when the index that is given by the user is 0. Now, when will the worst case scenario will actually appear, right? Let's assume that the singly linked list on which we are trying to perform the get operation has n number of nodes. So the worst case scenario will actually appear when we are trying to read the or get the value that is available at the very last index. That is, the index that user passed is equal to length of the linked list minus 1. In that case, we will have to start traversing at the head node, and one by one node using the next references we have to reach the very last node. That's why whatever the iteration logic that we are writing, right, it will get executed for n number of times. As a result, the worst case time complexity will be order of n in worst case scenario where the index given by the user is n minus 1, and in the best case scenario the index that is given by the user is 0 and the loop will not get executed and the time complexity will be order of 1. Now that is in terms of time complexity. Now let's just try to understand in terms of space complexity. Be it best case or worst case, what exactly we are doing inside, even if we execute the iteration logic that we are writing for getting the node, right, there we have basically defined two variables. One is to keep track of current node that we are processing, and the other is a variable called counter, which keeps count of how many number of times we are iterated. Basically it keeps track of, if the index is matching with the index that user has passed, right? And we know these two variables will take constant amount of memory. So obviously, even if it is the best case or worst case, same variables will be reused. As a result, be it best case scenario or be it worst case scenario, the space complexity will be order of 1 only. Why? Because we are simply using the same current node and counter variables for keeping track of the next node that we are processing and the index that we are currently processing. Okay, so that is the way we calculate the time complexity and space complexity for get operation on a singly linked list. Okay, in the next video we will see how can we reuse this get functionality for implementing the set functionality on a singly linked list. Okay, I'll see you there.